2A. No. So if you look over here, 2A, it says 1 league equals 5 to 80 yards. Remember, I just want you guys to think about this in pieces. With dimensional analysis, all you're doing is thinking about this in pieces. So once again to reiterate, all you're doing is, when you get any problem with dimensional analysis, this is how you approach it. When you're given any problem with dimensional analysis, all you have to do is write out your key. Don't get bogged down by the question. If you look at the question, they're going to give you a bunch of units of measurement, a bunch of numbers, that's going to get you confused. Don't look at the numbers, don't look at the units of measurement. All you have to do is look at the problem as a whole and write out your key. All the key is going to include is the unit of measurement you're starting with and the unit of measurement you want to end up with. So 2A says you're starting out with leagues, they want you to convert to inches. So we're going to have leagues in the beginning on our key and inches at the end in our key. Now all we have to do in the middle is somehow connect a league to inches. They're always going to give you the information. You don't have to have this stuff memorized. So we know that a league connects to according to this paper, yards. 1 league equals 5 to 80 yards. So a league connects to a yard. Okay, next, we know a yard can connect to feet. So we go from a yard to feet. And next, we know that a foot can connect to an inch. So now we've connected league to inches. Now we're good to go. So we got our key down, we're just going to follow the key. So that's the first step of dimensional analysis, is just writing out your key. The next part's even simpler. All you got to do is draw your brackets and add your labels first. So the first thing we start out with is a league, so we're going to put an L for league. That's our label, since we have L in the top left. To the bottom right, diagonally, we're going to have an L. Now we cross out that on our key. Next, just take a look at your key again. Next in the line is a yard. You're going to put YD over here, since we have YD here in the bottom right corner. Diagonal to YD, we're going to have YD for yard. Cross out YD. Next, just take a look at your key, follow that along. We have feet, we put a foot over here. Since we have a foot over here, we're going to have a foot diagonal to it, knock that out. Next we have inches, and since this is our last unit of measurement here in our key, we're going to circle it and we're going to stop right over here. We're not going to put another one here, we're just going to stop here and circle it so we know our answer is going to be in inches. Next, all you have to do is put in your numbers. You're given 710 leagues. You're starting out with that. Now all you have to do is connect these numbers. How do they connect? We know that a league and a yard connect, according to this worksheet. 1 league equals 5,280 yards. Remember, once again, you don't have to have this stuff memorized. All your stuff, all the information you need for this is going to be given to you. Even on the tax test, all this information is going to be given to you. All you have to do is write out your key, label your brackets, and then insert the numbers. So, feet and yards. We know according to this paper that 1 yard equals 3 feet. And we know that 1 foot equals 12 inches. So now all you have to do is multiply at the top. You get a number, and multiply at the bottom. You get a number. 1 times 1 times 1 is 1. And then you have 710 times 5,280 times 3 times 12 is going to give you a big number. You take this number, divide it by the bottom number, which gives you the number, still the same, and that is your final answer. So 710 times 5,280 times 3 times 12 gives me 134,956,800. So my final answer is 134,956,800. And that's my answer right there. Everybody got that answer? Yeah. You guys got it? All right. Good. So remember, I'm going to keep on hammering you with dimensional analysis. It's never going to go away. So you got to get this ingrained in your brain. And it needs to stay there until you get out of high school. Because you're going to need this in physics. But I promise you, in my class, you're going to learn it. And it's going to stick with you towards second nature. Okay, so for this dimensional analysis worksheet, I want you guys to go ahead and put it to the side. This is not going to be due. This is just for you guys to hold to kind of keep your mind on dimensional analysis, but you're not going to turn this in till November 10 or November 11. Whenever you guys turn in your tombstone project, you're going to turn in this paper with your tombstone, and this dimensional analysis side should be 100%. It should be complete. So that means you have till November 10, November 11. This is to kind of just do this on your own pace, just to kind of keep you on top of your game with dimensional analysis.
Game time.
It's getting there. It's getting there. We're almost there. Okay, what you guys are going to do? Okay, so what we're going to do is I want you guys to go ahead and this is going to be y'all's homework. This is to orientate you with the periodic table. This is going to be y'all's homework. I want you guys to pull out your notebooks real quick. We're going to take some real fast notes, and we're going to play our game. We're going to get through this quick. So I'm looking to do this in about 4 minutes, because we got to do this real quick so we can sleep through it.
I love Tommy though. So
Question about this.
I love both.
I'm trying to be quiet. You want us to do like
So
type
keep
of
Tommy by
number?
me. But I can be in the middle of them. I like them both.
Okay, so I want you guys to go ahead and pull out your notebooks. Okay, raise your notebooks out. Let me see who's got it, who doesn't. Notebook check, participation points.
Hold on, let me get one.
Okay.
Right here.
Okay, Damien, you got your notebook? Notebook. Okay, everyone put your notebooks down. Tristan, you got it, and Aristotle, the others. Okay, you guys can all put it. You guys, okay, got it. You guys can put it all down. And Shepard, you got it. I got you. Okay, what I want you guys to write down is lecture number 11. Box it, and you're going to write this down.
Nice. For real. Yeah, y'all being proud. This is like 6th grade stuff. We're juniors. We're just arguing. Why are y'all acting like y'all are acting like freaking 5th graders? Oh, we're still kids.
Oh, wait, so USPA started.
No, freaking elementary school.
Yeah.
How did you not have neutrons?
Well, see, it's kind of weird. You're going to find out the answer to that in about a week. So I don't want you to think too that, but that's a very good question. Very good question.
What do you
Yeah. But yeah, so with this, with y'all's worksheet, I don't want you guys doing the back yet, so don't worry about this side yet. Don't want you to do this side yet. All I want you to do is you're going to just take this and work on this. You guys may be able to actually finish this during class right now, but I want to do this front side. Jay. Yeah, and I'll show you guys how to do this. Okay, so and we'll get to that. So just put this worksheet to the side. We're just going to take some notes first. Okay, lecture 11, I want you to box it. There's 3 types of elements. Only 3 types of elements on the periodic table. You just have metals, nonmetals, and metalloids. I want you guys to write that down. This is lecture number 11, I want you to box it. Lecture number 11, and go ahead and box it. So there's only 3 types of elements.
How's your day, Mr. Paul?
It's great.
Go see the game today?
So what?
Go see the game today?
Absolutely.
Mr. Ball, do you like Rangers?
Uh-huh. You need to sit back there and look at it. And you grab this from somebody else. Okay, so 3 types of elements. You got metals, nonmetals, and metalloids. There's only 3 basic types of elements. Okay, now, these elements, we do know this. On the periodic table, which of these elements is the most abundant? Metals. Next comes what? The nonmetals, and then you have the metalloids. There's only about 7 metalloids. That means everything on the periodic table is mostly metals, then nonmetals, and then you only have about 7 metalloids. Let me show you guys
ptable.com.
what this looks like. We're looking at something a little bit different. Okay, here I'm going to move back. Okay, so what I want you guys to take a look at, just a basic form of the periodic table is this over here. This is what I mean by that. All you have is metals. These are all the metals which are green. Then you have the nonmetals. These are all the nonmetals that are orange. And then you have 1 hydrogen over here. That's a nonmetal. And then you have just the metalloids. You got about 7 metalloids.
Well, that's hydrogen way over there.
It's because it has atomic number of 1. And you're gonna all these answers that you're answering are very good questions. You're gonna find out all these answers as we start breaking through this periodic table. So I want you guys to go ahead and take a look at this worksheet. I want you guys to go ahead and put, number 1 says, outline the transition metals with a solid line. Now the transition metals, these are the transition metals, groups 3 through 12. So if you guys take a look at the board, let me outline it with my laser. So you have this over here is the transition metals. This over here are also transition metals. So, to just first illustrate this, let me show you guys on the board. I'm actually going to draw this on the board.
Cool.
So, these are the transition metals. From groups 3 to group 12, these are the transition metals. These also are included with the transition metals. So you have the transition metals here, and these are also transition metals there. So you're just going to outline that with a solid line. Okay, next, you're going to outline on your piece of paper, number 2 says, outline the noble gases with a dotted line. Where are the noble gases at? You guys should know this from your periodic table project. Group 18, very good. So it's all the elements in group 18. These are the noble gases. So we're just going to outline with a dotted line the noble gases, just like that. So you have your transition elements, here are the transition metals, and then you have the noble gas. Okay, number 3 says, shade in the metalloids. Shade in the metalloids. I'm going to show you guys a trick for the metalloids.
It's like a staircase.
Yeah, all you have to do is, for example, if you guys have something that looks like this, you guys should be able to just, if I give you a blank periodic table just like this, you should be able to tell where the transition metals are. You should be able to tell where the metalloids are. You should be able to tell where the noble gases are. It's real simple. So looking at this, okay, once again, let me just redo this. So we have the transition metals, just these guys here. All you have to do is look at this little break here. Transition metals are just right over here, so I'm going to box this and this down here. Then I'm going to identify my noble gases. These are just the noble gases. And now I'm going to find out what my transition metals are. For transition metals, all you have to do is you just make one mark here. This top corner here. You're just going to do one mark over there in that top corner. So, you're just going to make one mark right over here. Then you're just going to go diagonal to that, and then you're going to follow through with 2 marks. Like this. 2 marks like that. And then next, you're going to do the same thing. Okay. So you put 1 mark here, you're going to put 2 marks here, and then you're going to put another 2 marks right here, and then another 2 marks right here. So just kind of think of it as just something that goes kind of like this. You go, basically like, you're going to go like this, like that, like this, like that, and like this. So it's kind of like you're just drawing just a line through that. So you just put 1 mark here, 2 marks, 2 marks, and then going through 2 elements. So you have 1, 2, 3, 4, 5, 6, 7 metalloids. Does that kind of make sense? Is that sort of? It's 7. It's 7. I mean, it varies, but for this periodic table, we're just going to do 7. So I got 7 metalloids on there.
You want to shade it in right now?
You said what? Yeah, shade it in right now. So you're just going to shade it in?
How
So
are
that,
metalloids like different than the other ones?
we're going to get into that here in about a couple seconds. So you're just going to shade in those metalloids. So that's just where you guys can identify your metalloids. So just kind of think of it as something that goes like this, except this one doesn't count. So just kind of think of it as that centipede game. That's about the centipede game, old school Atari game, like real old. It's just going to go like that, and then you just cut off in the middle.
Guitar Hero.
Atari game. Okay, I want you guys to now put an X through all the alkali metals. All the alkali metals are these guys in the first group. So you're just going to put an X through all the alkali metals. And number 5 says put a circle over all the nonmetals. All the nonmetals is everything to the right side of the metalloids. So everything to the right side of the metalloids are nonmetals. So I'm just going to circle this, 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 this. All these elements to the right side of these metalloids, to the shaded ones, are just going to be nonmetals.
And hydrogen.
And hydrogen. Sorry, put an X on this one. That's going to be a circle there. So all of these are going to be nonmetals to the right side of metalloids, and that's going to be nonmetals. And then of course here, all alkali metals except the first one, which is hydrogen, that's going to be a nonmetal. And there you got it. That's the periodic table. You know everything about it.
Yeah, ones that are left over.
Those are just going to be just metals. These are post-transitional metals, but all you have to really know is just transition metals. Remember what I said? There's 3 basic types of metals. You got the 3 basic types of elements. You got the metals, the nonmetals, and the metalloids. So everything here are metals. Here you have the metalloids, and here you have the nonmetals. So if I can go back to my the periodic table example that I have here. Question, Jay. No, you circle that one. That was my fault. So that's just going to be you're just going to put a circle there because it's a nonmetal. So if I go back to my original poster board right over here, remember all we have is metals, nonmetals, and then we have the metalloids. But going back to what we wrote down in our notebooks, we have 3 basic types of elements. We have the metals, the nonmetals, and the metalloids. But there's different types of metals. There's different types of metals. Like you have the alkali metals, you have the transition metals, Same thing here with nonmetals. You have different types of nonmetals. You have the noble gas nonmetals. You have the halogen nonmetals, but they're still all nonmetals. They're just different categories of nonmetals and metalloids, or of nonmetals and metals. Does that make sense? So you just have three basic types: metals, nonmetals, and metalloids. And then you have different categories of metals, nonmetals, and then metalloids are just metalloids. Now let's talk about the differences. I want you guys to list down 3 characteristics of metals.
So it's like gold.
So 3 characteristics of metals, yeah. So if you think about gold, gold is shiny. If you think about metals, they're good conductors of electricity. They're typically solids at room temperature, and most are malleable and ductile. So I want you guys to write down 3 facts, or 3 characteristics of metals. And that's number 1 on this page. So 3 characteristics of metals. They have luster, which means shiny. If they're lustrous, that means that they're shiny. If you take a look at my little faucet there, most metals are always shiny. They're good conductors of electricity and heat. They're typically solid at room temperature, and most are malleable and ductile. Whenever it's lightning outside and you're stuck in a field, they always tell you to stay away from what? Trees or anything that's metal. You want to stay from anything metallic because lightning, it is a form of, it has a charge to it, electrical charge. That means that metal is going to attract that electrical charge. Therefore, that if you're near that metal, metals, of course, are good conductors of electricity.
So if you're in a car, are you supposed to be scared?
No, not necessarily, because I mean your car has it's all layers of different types of materials. It's not just solid metal. If you're sitting in a solid metal car, like your seat's metal, and like your steering wheel's metal, just everything's metal, then you're probably that's not a good idea. So, what does the word malleable and ductile mean? Malleable means, anyone seen Who Framed Roger Rabbit? Okay. Anyone seen Who Framed Roger Rabbit? If you haven't seen it, you guys should see it. It's a pretty cool movie. It's about cartoons mixing in with human beings. These cartoon characters, they always have something called a mallet. What's a mallet?
A big old hammer.
Big old hammer that you can just smash things with. Malleable, this word here means something that you can hammer in and shape. You take a blacksmith, blacksmith's got a hammer, he grabs some metal that's considered malleable because he can hammer out the metal and shape it into a sword.
Oh, I thought you were talking about Space Jam.
That's too. That has mallets in it too, I think. Those big old hammers.
Rocky and Bull.
That has lots of mallets. Okay, ductile. What does ductile mean? It means you can shape it into a wire. Remember I talked about a copper wire?
That can make electricity.
That can make electricity. Okay, next. Characteristics of nonmetals. If you can get the characteristics of metals on a tax test, nonmetals are just the opposite. So, I want you guys, using this PowerPoint, to tell me the characteristics of nonmetals. It's just the opposite. So number 2 says, name 3 characteristics of nonmetals. Number 2 says, name 3 characteristics of nonmetals. All you're going to tell me is the opposite. That means number 1, characteristic of a nonmetal, it doesn't shine. Number 2, characteristic of a nonmetal is the opposite. It's going to be they are not good conductors of electricity. Number 3 would be that they're generally gases at room temperature, down to the nonmetal slide. And number 4 would be that they're neither malleable nor ductile.
So I guess we can't play the game, huh?
We have time.
Don't.
We have 10 minutes. If we do it now.
Okay, so everyone got that. Okay, number 3 says, how are metals unique? Metalloids unique? Metalloids, to answer Christina's question, metalloids are unique because they have the same characteristics as a nonmetal and a metal. So metalloids have characteristics of both metals and non-metals. They have characteristics of both metals and non-metals. So, after you guys get done with this, I want you guys to go ahead and pass this to the front. So remember, metalloids have characteristics of both metals and non-metals. You hear what? Metalloids? They have characteristics of both metals and non-metals. They have both characteristics. Okay. So pass your worksheets to the front. So you're going to have to dress up for some school spirit.
So you said if it's laminated, I could literally do something?
Yeah, if it's laminated and you walk around with it the entire day. You don't have to do that side. Yeah, pass it to the front. I'm going to pick it up at the front. Are they doing announcements? Oh, because of tax testing? Are they doing that all week like this?
You do it now?
Yeah.
Man, I don't even know.
Trying to graduate earlier than people was bad last year.
Oh, yeah.
I can help you press out this stuff.
We won't have enough time for it.
What you make on your
Okay, so I want you guys to go ahead and take a look over here. I want you guys to read this PowerPoint right here. This one over here that I have. Take a look at this over here. Okay, silicon. Silicon, basically it is a metalloid. So silicon has properties of both a metal and a non-metal. So for example, if you guys take a look at a periodic table, this is a way to remind you. You have the metals all here on the left side. Then you have your metalloids caught right in the middle. And then you have your non-metals. Think about it like this. Metals are shiny. Non-metals are not shiny. Metals conduct electricity. Non-metals don't conduct electricity. Metals can be hammered. They're malleable. Non-metals can't be hammered. Metalloids are caught here in the middle as the front. Since these metalloids are caught in the middle, they have properties of both the metals as well as the non-metals. Think about it that way. So if you see silicon, silicon, for example, appears lustrous, which means what? It appears shiny, but it's not malleable, which means what? It can't be slammed or hammered by a mallet.
Mercury is a metal.
Yeah. Kind of, not necessarily. It's so weird, like, kind of sort of. It can be. It just depends on how it's made. Yeah.
Wasn't a metal ever seen a line?
Well, it's not necessarily all liquidy. It's kind of like it's more like a kind of soft sort of a weird material. It's not fully considered liquid. Yeah, it's more of a solid. Like, for example, with Jell-O, would that be a solid or a liquid? That would be more towards a solid. More towards the solid room temperature. Okay, so silicon has both properties of a metal and a non-metal.
Need help picking them up, Mr. Eric?
Yeah, just go ahead and grab those in front. Okay, so for y'all's periodic, for y'all's tombstone, you guys understand what you guys are doing for that, right? Yeah. Okay, so you guys just sit in your seats and wait till the bell rings. You guys can talk. You guys got free time to talk. Go ahead. On the periodic table marker? Yeah. Yeah, Ruben's coming by to go. So you guys just stay planted in your seats and just chill and wait till the bell rings. And let me see what you got there. Yeah, you did excellent. You got 100.
Was this my grade?
Let me give you a quick calculation here. So I can look at it in the computer without this thing up. Handbag after class. Handbag after class.
Hey, Arizona, I know victim, right? I know victim is like, that's like he said.
Hey, Christina. Okay, pull out your cell phone. I gotta ask you for it. So, you need to tell me yes or no.
Conflicts here or something. I was like pouring out. Like I had it in my hand because I was
Why you look so dark now?
Hey, try to tie up your left arm.
But do you want me to take it from you or just want me to
Yeah, and the all
Oh, tie it up.
it's not even that big over there. Yeah, you know what awesome.
Yeah, so I just keep it. And so that way, whenever who's your review? So yeah, he was probably like, so basically, yeah, I don't want you to get the so basically, this wasn't gonna happen. So I'll get you your homework and stuff. Everything's set up for next week. It sucks when you're gone for a whole week. I still got to do it. So basically, so I just gotta, like, the real thing is I gotta ask you, give me your cell phone, something else, then I just gotta write that down. And just hang back for a little bit too, so I can just kind of go over everything with you. Get it. You know,
Yeah.
well, alright. Yeah, I know. Okay then. Well, you know what you got in my class? You only got 100%. Got 105. Smart guy. Did you read this letter? I told him, I go, wow, you got 105 in algebra, and he's like, I know. But you only have 100 in my class, so it's not that impressive, Mr. Martin. Dr. Martin, not that impressive.